Okay, so let's take a look at 5.8, solving three-dimensional problems using trigonometry. So three-dimensional problems, it's very important that you understand that these triangles are going to be triangles flat on the ground and triangles mid-air and so forth with depth, height, and width. So let's take a look at example 1. It says, Doug is looking at a cliff. He determines that the angle of elevation to the top of a cliff is 54 degrees from where he is at. So then it says 50 meters away from Doug, Gary estimates the angle between the base of the cliff himself and Doug to be 26 degrees, while Doug estimates the angle between the base of the cliff himself and Gary to be 70 degrees. What is the height, h, of the cliff to the nearest meter? So let's take a look at this. I'm going to draw this in a three-dimensional perspective here. Here is the cliff, okay, and this is the height of the cliff. Now, it says Doug is looking at a cliff, and he determines that the angle of elevation to the top is 54. Now, instead of drawing 90 degrees this way, I'm going to draw this triangle coming out of the page. It's kind of hard to do that, but this triangle is coming out of the page, and let's say that this is the top of the cliff, this is the cliff here, and we have to figure out the height of this cliff. And here is Doug. And Doug is looking up at the cliff, and this is 54 degrees. Okay. Now this triangle is coming out of the page again, like as I said. Okay. The reason I'm doing that is because 50 meters away from Doug, Gary estimates the angle between the base of the cliff himself and Doug, okay, to be 26 degrees. So the base of the cliff is here, himself and Doug. So let's put Gary somewhere else on the ground. This is a bird's eye view of where Gary is. And Gary is 50 meters away from Doug. And this forms a triangle that's a bird's eye view. So this is flat on the ground. This is mid-air. So it says that Gary estimates so he's 50 meters away from Doug. Gary estimates the angle between the base of the cliff, which is here, himself, and Doug to be 26. So from the base to Gary to Doug, so that's this, to be 26 degrees. While Doug estimates the angle between the base of the cliff, himself, and Gary to be 70 degrees. So the base to Doug to Gary is 70 degrees. Okay? So it says, what is the height of the cliff? So this is what we're looking for here. So somehow, some way, we're going to have to find h. Now, if I break up that triangle that's in mid-air, and it looks like this, where this is height, and this is the base, and this is Doug. This is 54. Now, we have to find height, but we don't have any measurement. It would be very easy if we had this measurement here. Let's say call it x, which is the same as this measurement here, x. Now, we can find that because this other triangle right here, we can use, this is not a 90-degree triangle, of course, because we know that this angle B is going to be 180 minus 70, which is 110, minus 26, which is 84. So angle B is 84 degrees. And we can use that angle and the rest of the picture to figure out x. So this is 84 degrees. And we're going to figure out this x using the sine law of this triangle here. See, I have an angle with its opposite side, and I have this angle, and I can find its opposite side. So I'll set that up, and I'll set it up as little x all over sine of 26 is equal to little b, which is 50, all over sine of 84. Continuing this, if I cross multiply this, I'm going to get 50 times sine of 26 all over sine of 84. So x, and I'm going to keep all of these numbers here, 50 sine of 26 equals and divided by the sine of 84. And I'm going to get 22.039290088. That's what x is equal to. So now I can use this picture here, and I have what x is equal to. X is equal to 22.03, all that stuff. I'm going to write all that. And now, using this 90-degree triangle, 90 degrees allows me to use SOHCAHTOA. According to this angle, this is the opposite side, and this is the adjacent side. So I can use tan. Tan theta is opposite over adjacent. So in this case, I have tan theta is 54, is opposite, which is height, all over adjacent, which is that 22.03929088. I realize it says to round to the nearest tenth of a meter, but that's only the final answer you should round. So H is going to be equal to the 22, actually I'll just write answer here instead of rewriting that. That answer times the tan of 54. So you already have this answer in on your calculator, so I didn't erase it, and I'm going to multiply it by the tan of 54, and I'm going to get 30.3 when I round it to the nearest tenth. Okay? So remember to always round to the nearest tenth at the very end, never during the problem. I understand that if you round it to the nearest tenth here and use 22, maybe you still get 30.3. But sometimes you have to use this answer to find another answer, and then to find another answer, and so forth. If you're rounding here and you're using a rounded answer to find another answer, and then you're rounding this answer to find another answer, and so forth, your answer may be off. Okay? So let's always remember to round to the nearest whatever it asks us to at the very end. Just stay tuned to part 2 of my video to do example 2.